In this video, we're continuing with lesson 8.4, but now we're going to focus on part 2, which is dealing with solving exponential equations. And you may be thinking, well, we've already done that. And that's kind of why I have this stuff up here on the previous page for it is we have solved exponential equations before. So I did the problems already just so we can kind of talk through it and save some time, is we've created common bases before. I could change 25 into 5 squared without changing the value at all on it. And it allowed us to solve and get the value for x. And the same thing, 9 and 27, I could create a common base of 3. And I could change 9 into 3 squared and 27 into 3 cubed. And by creating that common base, we would be able to solve. Now, these exponential equations are nice. And these are nice because you have the ability to create a common base. So these two are kind of review of a previous lesson. We can create a common base to solve. But the question is, what if we can't? So what if we can't create a common base? All the previous problems that we gave you dealt with the ability to create it. I always gave you one that you would be able to change on it. But if I look at these problems, 4 to the x equals 51. I mean, look at this. 4 squared is 16. 4 cubed is 64. Well, I passed 51. It's somewhere in between those two. I can't create a common base. So if you cannot create a common base, then you have to apply logarithms on it. Now, there's two approaches, and in this video, I'm going to show you both, and I don't care which one you do. There is one that is log both sides and apply the power rule, the LAP approach. Or there's one that actually applies the definition of logarithms, which is the question, what power of blank gives us blank? And then we can use our change of base approach. So I call it the COB approach, change of base approach. So log and power, LAP approach, or change of base, COB approach. So we'll do the log and power first for number 1. So if you cannot create common bases, so what if we can't do it? What you do is the first part. You are going to take the log of both sides. So I'm going to take the log of 4 to the x, and I'm going to take the log of 51. You're going to log both sides. And then I'm going to apply the power rule on it. So that means I can take this exponent of x and bring it down in front. So it says x times the log of 4 equals the log of 51. Now, the reason why I like to write this dot for times here is because that allows me to see the next step. If I want to solve for x, I want to get rid of the log of 4. So I'm going to divide by the log of 4 on both sides. And that allows me to get rid of the log of 4 on this side. And I am left with x equals, it looks like I'm going to need my calculator for this. And so I'm going to type in so I can see it. I'll have log of 51. Now remember from the previous video, close the parentheses, divided by log of 4. 2.83621. So if I'm going to 4 decimal places, that is 2.8362. And that is the log and power approach. Now this is a basic problem. We increase the difficulty as we go through the problems on it. That's log and power. Now the change of base approach is something that I find really interesting on it. Is it really asks the question. And remember the question I'll write up here was the what power of blank gives us blank, and we used this log, and I'll go base, and let's try and make it so it's color coded on it. So let's go blue. base of our number equals, and we'll go purple, power. I mean, this was back when we first introduced what is a logarithm. It's that question, what power of blank gives us blank? And I can ask that question even on this problem. I can say, okay, what power of 4, because 4 is my base, so what power of 4 gives us 51? So if I look at this part right here, what power of 4 gives us 51? And it tells me the power. It says the power is x equals x. Well, that's what this previous part was. I can use my change of base formula here. We did in the previous part. I can take the change of base. I can do log of 51 and divide by log of 4. Log of my number in the numerator, log of the base in the bottom. And that equals x. And that we already found to be 2.8362 approximately. And so if I look at the steps, I want you to kind of put them side by side and notice they are almost identical. At some point, I divided by log of 4 on it. So we can kind of see that the steps are going to be the same, but it's really which one is more consistent to you. Now, if I'm going to be honest with it, most students prefer to use this part, the log and power, because it's the most consistent. No matter how difficult the problem is, it's always going to be the same steps. So if you like consistent steps for solving, log and power approach is the way to go. I love concepts. I love thinking. I have gone into really going and using the COB approach, the change of base approach. And I don't care which one you use, it's which one you're more confident with. So if I look at number 2 on it, as we go through, I'll separate them, make it easier, is we'll do the same thing. We will do the log and power approach. And so the log and power approach is really what it says. Take the log of both sides. So I'm going to take the log and write the log to the left of the number equals, and I'm going to do the log of 195. So log and power. So I'm going to take the power and I'm going to bring it down. And when you do that, put it in a parentheses, 2x minus 3, because it's an entire object, times, I'll put times there. Let's go back, stick with the color coding of black, times log of 5 equals log of 195. Now, technically, when you have a number outside of parentheses, you want to distribute it, but in this case, I'm not going to. I'm going to follow the same steps I did on the left side. That's why the parentheses is nice, is I'm going to get rid of the multiplication by dividing the left side by the log of 5. And if I do that on the left side, I'm going to have to do that on the right side. And that would cancel it out here. So I'm left with 2x minus 3 equals, in this case, I'm going to use my calculator. It was log of 195, close the parentheses, divided by log of 5. 3.27629, so it would be 3.2763. So 3.2763. So now this is an easy one to solve. You're really going to need calculators for it with the logs to go through and get the answer. And I'm going to get 2x equals 6.2763. And then we're going to divide that by 2. So I have 6.2763. And I'm going to divide that by 2. And I get 3.1382 approximately. And so there we go. We have it. We did the log and power approach. We are good with it. It's the same steps as the left side. That's what I'm telling you. If you like consistent steps, you really want to probably use the log and power, the lap approach. It is the same thing. I took the log of both sides. Look at the blue. I did the power rule, look at the green. I then divided by what was outside the parentheses, look at the red. The steps are the same. So if you love consistent steps, log and power. If you love concepts like I do, you're going to use the Cobb approach, the change-based approach, which is really going to be the question. What power of blank gives you blank? I mean, I love the fact that this is the original thing we learned with logs. It goes back to what we know. Is I'm going to ask, what power, my base of 5, what power of 5 gives me 195? I mean, that's what this would be if I were to convert it to a logarithm. What power 5 gives me 195? And the problem tells me, it says the power is 2x minus 3. I mean, that's just converting exponential form into logarithmic form based off the question. The first lesson in this chapter. So when we go through, I can use my change of base. Log of the number in the numerator, log 195, divided by log of the base in the bottom, divided by log of 5 equals 2x minus 3. And so if I were to go through, notice the steps are going to be almost the exact same from this point on. If I take those numbers and divide like I did, I'm going to get the same thing. And then I'm going to add, so I get 6.2763 equals 2x. And I'm going to divide, and I'm going to x equals about 3.13815, so round that up to a 2. I mean, look at that. The steps up from here down are the exact same. So that's why it doesn't matter which one you do. It's which one you're more confident with, which one you understand more on it. And so that is the Cobb approach. Let's go to number 3. And again, we'll do the 2 approaches on it. We'll do the most consistent one. We'll do the lap approach. We'll go log and power on it. So I'm going to sides and I'll put log and so plus 7 equals, put log of 54. So it's exactly what the directions say. Take the log of both sides and then apply your power rule. And so this is going to come down here. And so I'm left with 4. I'm left with 4x plus 7 in a parentheses because it's an entire object. Notice I circle it, so I'm going to put it in a parentheses. I'm going to put it down for multiplication because that kind of helps me see the next step equals log of 54. Because the next step is I want to get that object, that parentheses by itself, so I'm going to do the same thing. I'm going to divide out my log on both sides because that cancels it out here, and I'm left with 4x plus 7 log 54 divided by log of 2. I'm going to do something a little bit different. I'm going to hit the alpha y equals, create the fraction, log 54 over log of 2, hit enter, 5.75488, so 5.7549, 5.7549 on it. And now, I mean, it's decimals, it's going to be nasty, but we're going to just solve it the way we normally would. We would subtract the 7 on it, and that's going to give me negative 1.2451, and then I'm going to divide that number by 4, and I mean, x is approximately negative 0.311275. I want to go to 4 places. So I'm going to look at the 5th place. That's going to round that 2 up to a 3. And there is your log and power approach. It's the same steps as 1 and 2. I mean, look at that. I took the log of both sides. I brought the exponent down doing the power rule. And then I divided by what was attached to the power, the log. And then I just solved a normal equation. So consistently, it's the same thing. Now let's grab, so I don't have to rewrite it. Let's grab this. Because I'm a concept person, I love just reading it and translating it based off the question. What power of blank gives me blank? So I have what power, my base is 2, so what power of 2 gives me 54. And the problem tells me that power is 4x plus 7. That is just translating back from the first time we learned logarithms. 7. So I'm just translating it, and then I use my change of base. I have log of the number in the numerator, so log of 54 divided by log of the base in the bottom, log of 2 equals 4x plus 7. And notice, here to here, I mean, look at that. Our steps are going to line up the exact same. So my steps are going to, I'll have 5.7549. If I type it in my calculator like I did, 4x plus 7, dot, dot. I mean, it's going to be the same exact steps as I solve. So I'm not going to finish the problem doing the change of base approach, because it's going to be the exact same as what is on the left side here. So I can just do this if it makes you feel better. There's the answer on it. So there's number 3. Again, whichever one you want, log and power or change of base. Now, when you get to the more difficult problems like number 4, this is where those students who really prefer consistent steps or consistent process for solving that log and power, this is where they kind of shine more. Is if I were a student, I was struggling on this, it's more consistent, especially when you have 2 variables. So when you have 2 variables, I mean, I would probably use the log power approach. It's safer, but I like to have fun, so I'm going to use the cob approach also. But let's start with log and power. So I'm going to take the log of both sides. So log, put it in front, 3 to the x equals log of 15. Now this one's trickier because you have variables on both sides, and you have powers on both sides. So I'm going to use my power rule here to bring that x down. So x, I'm going to put the dot times log of 3. That's not new. However, there is a power on the left side and the right side. So I have to do the same thing to the right side. And since it's an object, I'm going to put it in parentheses. X plus 2 times the log of 15. Now, if I were to go back, I'll look at number 3. The next step was always divide by the log. And so the problem I have here is, which log do I divide by? The answer is it doesn't matter, but there's always a smarter one. And the one you really want to divide by is the one that's attached to the more complicated expression. And usually that's the one that's attached to the parentheses. Because if I don't get rid of this log, if I don't get rid of this log of 15, I'm going to have to distribute it inside that parentheses. And I don't want to do that because then it's going to be ugly decimals. So I'm going to divide by whichever side has the parentheses. So divide by the log that is attached to the more complicated side. And I'm going to divide by log of 15 on the right side. So I'm going to divide by log of 15 on the left side. And so that's going to give me on the right side x plus 2. I can drop the parentheses because there's nothing outside. So always when you have 2 variables, divide by the log is on the more complicated variable expression side for the power. So log of 3 divided by log of 15. So I'm going to have log of 3 close parentheses divided by log of 15 on it. And that's going to give me 0.4057. So 0.4057. Now be very careful because you do have this x here. So it's 0.4057x. And if you need help, you can put a 1 here to show us on it. 0.4057x. I have a 1x on their side, so I'm going to subtract it. So I'm going to get negative 0.5943x equals 2. When I take 2 and divide by that negative 0.5943, I'm going to get negative 3.3653. So negative, and I'll fix the way this looks, negative 3.3653 on it. So it gets more complicated when you have two variables, no matter what, but the consistent way to do it is the log and power approach on it. So I inserted my coefficient of 1 to make it easier. That allowed me to see that I'm going to subtract 1 to get the x's on the same side to give me negative 0.5943. I could also do my change of base approach. Like I said, if I were being safe, I would use this approach on it. But I like to have fun. I think logarithms are really interesting. And so I'm going to use my change of base approach. So let's try it out. But before I try it, which side do we say was the more complicated side? And the sides that's the more complicated side is x plus 2. So when I write this, I'm going to read it backwards. And I'll rewrite it so you can kind of see left to right. 15 to the x plus 2 equals 3 to the x. So I have what power? In this case, my base is 15. So what power 15 gives me, and this is my number is 3 to the x. 3 to the x. And the power it says is going to be x plus 2. So when I go and do this, I'm going to use my power rule to bring this x down. So I have x times log base 15 of 3. And I'm just going to write it here. This is my change of base. I can do log of the number divided by log of the base. And notice that is this step right here. I'm going to get 0.4057x equals, and I'll put the 1 there, 1x plus 2. So the steps do line up. It's more complicated. It's not as safe as the other one. So your choice. Do the log of power approach, or you can do the change of base approach. But if you want consistency, if you want the same steps every time, you probably want to stick. Because when I give you more complicated problems where there's two variables, one on each side, the change of base is not as safe, is not as logical for it. But this is part 2 of lesson 8.4. If you have any questions, please reach out and ask.